Good afternoon, everyone, and welcome to the wall framing webinar. My name is Nick, and I'll be doing the presentation for you today. Just like all of our previous webinars, this will be recorded, so you can go back and watch this at any time. And everybody is on mute, so if you do have any questions at any point during the presentation, please feel free to go ahead and enter that into the questions area. And at the end of the class, I will go through and answer any questions that have come up. I will also be sending out a PDF form of what we've covered today at the end of the class, so that way you have some documentation to refer back to as well. Again, today's class is on wall framing, and my name is Nick. I'm just going to go over a quick lesson overview of what we're going to cover today, and then we're going to jump right in. So in today's class, we're actually going to look at how you can review and frame your walls. We're going to learn how to customize your wall framing in detail to meet your specific construction needs. So to do that, what we're going to look at is looking at your wall framing settings, and then actually looking at a framing mode option. So first we want to talk about our wall framing. So every building location in your project has a number of framing options assigned to it that determine how the walls on that location will be framed. These options include your span tables, which determine how your openings should be framed, your infill, which is your stud, top plate, bottom plate configuration, your framing rule, which is the direction in which your walls are framed, and then an intersection lookup table. And this determines how your intersections are going to be framed as well. You can select the framing member that you want to use for your walls. You can also customize the framing settings for each building location in your project. You can define custom framing settings for individual walls, openings, and intersections by going into the framing mode. In this mode, each framing component, your infill, opening, and intersections, have special highlighting applied to them for ease of identification and selection. The catalog ships with predefined libraries of your Headcell jam tables, wall opening span tables, and infill configurations, but you can edit or add to these libraries to meet your specific construction needs. Wall framing settings. Each location in your building locations dialog has a set of framing options that determine how walls, openings, and intersections on that location will be framed. Location framing options include a span table selection for walls, an infill configuration, a framing rule, and an intersection reference table. We're going to look at the available wall framing settings. So we're going to open up our building locations. So you can do this in one of two ways. You can go up to settings and select building locations, or if you like to select the button option, which is right in your face, you can actually just select this button down here in the lower left corner. That will bring up building locations for you. So again, depending on your preference, you can use the menu option, settings, building locations, or you can use the button option in the lower left-hand corner, and that will bring up the exact same dialog. Once we have this dialog open, we're actually going to look at the framing options column. So we've already talked about all these other variables before in previous webinars. We're going to focus on the framing options column here. So in the framing options, when I select this for the ground floor and I click on the little browse button, it's going to bring up the location framing options dialog box. And here we can actually define our wall framing settings for each location. Here we can define our wall framing options for our different spans. So here we can go in and we can select the location for load bearing. And if we select the load bearing option, we are able to actually go in and adjust the type of configuration we want to apply for any load bearing wall that has an opening in it. So in this particular case, the load-bearing walls will have a larger header assigned to them than any non-load-bearing wall would. So that's why we break this up into those different sections, because you may have different framing for different walls depending on what they're being used for. So here we can say any load-bearing wall is going to use a specific span table. So here I can select this option, and if I double-click in this area, it'll bring up the wall span table library. And in here, I can define what type of wall span table library I want to use for that load bearing wall. So let's say, as an example, all my load-bearing walls are going to use a 3-ply span table. Now, inside these actual span tables are actual configurations that you can set up. So by double-clicking on that, it will bring up a wall framing span table dialog box. And in here, you can customize the actual spans and what you want to use for those spans. Again, this is all predefined or default within the program that we send out. You can customize this. So here you can add new opening sizes if you want to. You can edit based on the spans that we already have created. But all we're saying here is anything up to 5 feet is going to use a 3-ply 2x6 header. Anything 5'1" to 8 foot is going to use a 3-ply 2x8 header with a double sill, and so on in that list. So you can specify exactly what size of head sill configuration you want to use based on the opening for that load-bearing wall. Just going to click cancel on that, and we'll say OK. So now you can see that on my ground floor, my load-bearing span table is set to be using a general 3-ply span table. I can again make this adjustment to my non-load-bearing walls. So any interior wall that is going to have an opening in it is not going to need all that extra member to support anything above it. So here you can adjust this so that it uses a smaller configuration for those headers. Again, you can control how that's going to look. If I go back into this option here, one thing I did want to point out as well is you can actually specify a different option. So again, if we wanted to say I want to use for my garage or anything that's going to be using a longer span, I don't want to use a 3-ply 2x12 header. I want to use, let's say, a PSL. So here I would go in and I can select a different option. And I'm just going to click on that little browse button, and that'll bring up the Headcell Jam library. And again, these are all predefined defaults that are shipped with the program. You can again go in and customize these to define exactly what you want. I'm going to double click on this 11 7/8 PSL header just so that you can see exactly what it's going to use. And in here, we can go in and say, I want to adjust this actual header, and I like to turn this into a rendered outline view so that you can see exactly what we're working with. So in this particular case, this PSL header has a double king stud and a left and right jack stud. You could say, well, I actually want to have a double jack stud on this particular opening because I want 2 studs to hold up this beam. So you would be able to go in and select the left and right jack stud and add in a duplicate of it to create that type of configuration. So these are where your actual Headcell jam configurations are being taken from and how they can be edited. And we'll touch on that a little bit more later as well. So I'm just going to cancel all of this. And we're going to say, next we're going to look at our wall infill. So in the infill configuration, here we can control how the wall is actually being framed itself. So the infill refers to the materials that fill the volume of the wall. An infill configuration determines what types of members are used for your studs, top plate, bottom plate, and very top plate. The spacing between studs and the way in which members are aligned and rotated. I see someone has their hand raised. Is there any issue that you're having with volume, or do you have a question? If you do have a question, just go ahead and type that into the questions area, and I'll go and refer to that if you do have a question at the end of the class. And so when we're in here, I'm actually going to go in and we have the infill configuration option selected. And right now it's using a 16-inch on center double top plate, and it's using a blocked wall. So in here, I want to actually go in and change this because I want to use a different option. So I'm going to go into this and I'm just going to double click. That will bring up my wall infill library. And I want to use a different infill. And again, this is a pre-populated list of all the different infills that we ship with. And again, you can add to this. When I go into an actual, let's just select the 16-inch on center double top plate, and I double click on that, This will go in and it will specify exactly what we're using. So if I look at the Infill Properties, it is telling me how the studs are going to be spaced, which is going to be at 16 inches on center. I have an interference option, which basically just lets me control anytime there's another wall intersecting with it, that interference, that's what that's referring to. It's going to find that stud and move it to the nearest intersection. So it's just going to move that stud around for us so that it meets that intersection. By default, we have cut opening bottom plate turned on. We do this because most of the time this is something that will be built on site. So you would actually cut the sill out or the bottom plate out whenever you have an opening. But we do have manufacturers who build panels off site, but they want the bottom plate to be intact until it's delivered on site because it makes it a more rigid construction. So what you can do here is you can uncheck this option if you're using manufactured wall panels. That way that bottom plate stays intact until it gets to the site. So again, just another control that you can adjust. This top extension, base extension for studs, wood studs is going to be 0, but if you are using a metal framing option, you can actually extend this into the bottom of your top plate or into the top of your top plate or bottom of your bottom plate like you would with steel framing. And then we have generate end studs. And by default, again, we have an end stud and a start stud on by default. When you look at your bottom plate, it's going to allow you to specify an exact bottom plate. So here we're saying we want to refer to our wall framing member. So what this is essentially saying is whenever we draw in a wall, every wall has a wall member already assigned to it, be it a 2x4 framed wall or a 2x6 framed wall. It's going to use that particular member. If you're building on a wood platform, then you would just use the wall member that's assigned to that wall, be it a 2x6 or 2x4. However, if you're building on a slab on grade, that bottom plate needs to be something different. So it could be a pressure treated bottom plate. So you would actually need to go in and specify an exact member for that. So that way it's using something different than what is assigned to the wall itself. So you can do that by where it says use member from wall properties. I'm going to say no, I want to use it from the member library. And then from the member library, I can go in and say under my exterior grade lumber, under my 2x6, I want to use a 2x6 treated bottom plate. And that will allow you to define that bottom plate and just that bottom plate as a different member. I don't need to do that for this wall, so I'm not going to go through that process. I'm just going to cancel out of there. But again, that's how you can go through and make those adjustments to use exactly the type of member that you want. Same is true for studs. You can go through and specify the exact stud that you want. And if you notice, anytime I select something, it is showing up in green on the right-hand side. And again, I like to use the rendered outline so you can see all the different lines and what we're working with for components. So again, here we can see all of our studs. Again, our studs are going to use the member from the wall properties. We can actually have it set up so that the quantity information is using an actual usage and a phase. So this is going to be a stud with a phase of wall framing. This phase is actually going to be how it's delivered or when it's delivered on site. So you want all your wall framing materials to be delivered at the same time, so that way you can build your walls. That's why we have these phases set up for you this way. We can also position along the wall. We have our anchor 2 option, so you can stud reference line, so you can specify how you want that stud to be centered in that wall. And here we have it actually centered in that wall itself. And then we have position from front to back, anchored to the bottom plate. Again, we want that to be in line with our bottom plate. So we're going to have that set to mid to mid. You can adjust this. So if I was to grab this and move this over, you can see that it would move my studs to the edge of the bottom plate. So again, you can make adjustments on exactly how this is going to be lined up. But since we're working with a 2x6 member and a 2x6 bottom plate, it should be set to mid so they line up exactly on center. If you had blocking assigned to your wall, you could apply blocking in here, and then you can actually space this however you want. I'll skip that for a second and we'll come back to that one. I'm going to go to the top plate option. In here, we can go in and again specify a top plate. Again, it's probably going to use the same member that's being used in your wall framing. So it's going to be set to wall properties, and it's going to use that framing member from the properties of the wall. Again, you have a usage and a phase, and you have a position anchor to the bottom plate, and again, it's going to be set to mid. And then your very top plate is going to be the exact same as your top plate. So if I go back to blocking, I can actually go in and say new. So I want to create a new blocking member. And I'm just going to call this blocking. From in here, I can say, again, I just want to use an actual member that's assigned to that wall. So it's always going to use a 2x6 because that's the type of wall that I have inserted. And it's going to use a 2x6 member for that. Usage, I want this to be blocking. So I can bring up that blocking option. I can say phase. Again, it's going to be wall framing. So I'm just going to select wall framing as my phase. And I can now achieve how I want this to look. So I do want this to break at my studs. It's not going to be a solid member that goes all the way through. They're going to be individually cut pieces that fit in between my studs. So break at stud, yes. I can also set a position bottom to top. So from the bottom plate, I want that to be initial offset of 4 feet. Here I have a spacing option and then a stagger. And I do want this to stagger because it's going to be kind of hard to nail these in if they're all in line. So I want to stagger this. So I'm going to say yes. And it's now going to automatically stagger those for me so that I can easily nail one past the other without having any kind of interference. I can also go through and again position this from front to back. And again, I have this set to mid because I do want this to be right in between my actual studs in line with my bottom plate so that they all line up and fit within that cavity. So that's how you would go about adding in an element and making adjustments to the actual infill. I'm just going to click cancel because I don't want that blocking to be applied to that. And I'm going to say OK to that wall. So now my infill for my ground floor is using a 3-ply span table for any load-bearing wall, a 2-ply span table for any non-load-bearing wall. I have my intersection lookup table using a turn stud, and we'll reference that in a bit. It's just you can't access the library for this in this dialog. This is only a reference to a particular library, and a particular library we're using is turn stud. So if I double click on that, I can access any one of these 3 options here, but turn stud is the one by default. But I can't edit any of the configurations in here until it's actually in the drawing. So I'm going to say OK. And then we have our actual framing rule. So here you can go in and you can go into the actual framing rule and adjust how you want this to be framed. So from the bottom left, and you have a bunch of options in here. You have from bottom left, from bottom right, top left, from the start of your wall or from the end of your wall. So these are just going to allow you to specify exactly where you want your wall to start when it's framed. And you can pick the left or right side. I'm going to leave that as from bottom left. I'm going to say OK. And then I'm just going to click OK to that dialog. So this is going to bring up, and we're going to see our actual model here. Now, I do want to take a second to talk about intersection framing because we can't actually access it until we look at it in the model. I just want to talk about it here. So each builder frames intersections in a different manner, and that will change within a model from one intersection to the next, depending on its type and orientation, be it an inside corner, an outside corner, or a T-intersection. Each wall intersection in your model is framed using a standard intersection framing configuration designed specifically for that type of intersection. Intersection framing configurations are stored in an internal library called an intersection lookup table. The program matches the intersections in your project with intersections in that lookup table to determine how each intersection should be framed. Since there are so many intersection possibilities, intersections are defined on a per model basis directly within the model itself. The intersection lookup table simply retains the options you have chosen within a model. Intersection framing can only be defined in framing mode, which is a specialized viewing environment that highlights and focuses on wall framing components. And that's where I was saying this lookup table is only accessible in the model itself. Because there are so many different options for it, having the model already create that intersection, once it's in there, you can now go in and modify it even further. So that brings us to our framing mode, and that's the next thing we want to look at. So when in framing mode, your framing components, such as your wall infill, intersections, and openings, are displayed as colored glass boxes, which make it easy to identify and select each one. You can see these glass boxes in both 2D and in 3D. So we're in a 3D view, so I'm going to stay in that view. And we're going to look at the framing mode, which allows you to override the location framing options and specify your custom settings for individual walls, openings, and intersections in your model. Clicking on a wall will let you select the infill configuration, the framing rule, and the wall opening span table for that wall. Clicking on an opening lets you select the opening span table to be used for framing that opening or define a custom Headcell jam configuration for that particular opening. And clicking on an intersection lets you select the intersection framing configuration that you want to use for that particular intersection. So right now in our 3D view, we see our actual model. So we actually want to go in and we want to see this framing mode. I want to see those glass boxes to define those particular regions. So to do that, you're going to go down and you can actually select under View, Framing Mode On Off, or down in the bottom here, you can use the button and select Framing Mode On Off. So here, by reselecting it, it turns it off. That'll turn it back on. So right now we're looking at our 3D model and we can see a bunch of different glass boxes. So orange, this is your wall infill for any load-bearing wall. As you can see, I've defined all my exterior walls to be load-bearing, and I specified this one interior wall to be load-bearing. I also have a green wall on my inside. That is denoting a wall infill that is a non-load-bearing wall. I see these red or wine-colored glass boxes. These are all of my openings, be it a window, a framed opening, or a door. These are all different options that are going to allow me to adjust each of those particular openings in an individual way. So if I want one particular opening to be a different size, I can make that adjustment so that that header for that particular opening is a different size. And then we have our blue glass colored box here. And this is our intersection lookup tool. And in here is where you can go in and define how you want that intersection to look. So first, let's go in and let's select a wall infill. So let's say that this wall, and this wall is our kitchen. So I want these walls to be blocked. So I want to make some edits to just these three particular walls. Again, to do that, select one wall, hold your Shift key down, and you can select the other two walls. So I now have three walls selected. Two are cyan, one is green. I can now go in and say right-click, Properties, and it will bring up the Edit Infill dialog box. And here you can select the infill configuration, the framing rule, and the wall opening span table for the wall that you selected. You can also use the location framing options for each or select custom rules and configurations. So let's say I want to say, well, I want the infill on these walls to use a different infill based on what is in my building location. So instead of refer to location, I'm going to select use custom infill configuration. I'm going to select the select custom options configuration. And here I'm going to go in and say, well, I want this to be pretty much the same as what is already there, but I want it to be a blocked wall. So I want it to be a 16-inch on center, double top plate, but I want it to be blocked. And I can say OK, and then I can say OK. And now just those three walls now have blocking assigned to them, and the rest of my walls do not. So that's how you can go in and adjust the actual wall infill for individual walls in your design. Now I want to talk about adjusting openings. So let's say that this particular opening here is going to be carrying a load above that is a bit that's heavier than the back opening over here. So I want this opening to be a different size header. So to do that, what I would do here is I would just click on that glass colored box and I would double click on it, and that will bring up the edit opening dialog box. In here, you can select a custom Headcell gem configuration for that particular selected opening. I'm going to go in and say use custom Headcell gem configuration, and right now it's set to none. I'm going to say I want to select that configuration. This will bring up the Headcell gem library that we were talking about earlier, and I can now go in and say, well, I want to use a different Headcell gem configuration for this one particular opening. And I'm just going to go in and say, I want this to use a 3-ply 2x10 header. And I can select that option and say OK. And when I say OK, we'll be able to see that it changes the size of that particular opening for that particular header. That one is probably a bit too big. So we're going to go in and say, let's just do a 3-ply 2x6 header, and we'll say OK. And we'll say OK. And now it changes that particular opening to use a different header. I can go in and add in a different type of header as well. So if I want that to be a PSL header, I can add that in, and it's disappearing because it's interfering with the top plate. So that's just letting me know that that opening isn't big enough for that type of header. So I would need to either adjust the wall height or reduce the size of my header. So that's why we're just going to use we'll do that 3-ply 2x6 header. So again, you can control that particular header for that particular opening. Next, we're going to look at the intersection. So the edit intersection dialog box will appear when I double click on any corner. And again, I like to turn on the rendered outline view so that we can see exactly what we're working with. And by default, it's using the 3-stud energy corner. So what that entails is 2 studs that are on the end of one wall and 1 stud on the end of another wall. That's where we get the 3-stud from. And it's called an energy corner because it is actually using a gap in between the 2 studs that you can pack with insulation. So that's why they're calling this a 3-stud energy corner. You can say that's not how I frame my walls. I'm not going to do that. I want to select my own custom option. So here you can go in and say custom, and now you can specify exactly what you want. So we have a 4-stud corner. So here we have 2 studs on the end of one wall and 2 studs on the end of another wall. 3 studs on the end of one wall and 1 stud on the end of the opposite wall to create that 4-stud corner. Again, just further control that will allow you to specify exactly how you want that to be framed. I'm going to go back in and I'm going to select that 3-stud energy corner, and I'm just going to click Edit. This is going to bring up the wall intersection dialog box. The dialog box is divided into a wall core section and a very top plate section so that you can customize both parts of the wall at the corners. Again, I like to turn this into a rendered outline view so that you can see exactly what we're working with. And here we can see that everything is labeled. So we have wall A, which is highlighted with that A at the top there. And if we can put that into a 2D plan view, you can see exactly what we're working with. So I can see wall A and wall B. So right now I'm saying wall A is the relative wall is wall B. And I have this set to the trailing edge of wall B. So when I look at this and I turn off the very top plates, I can see that wall A is going to extend all the way past wall B to its trailing edge. If I had this set to leading, it would move wall A to the leading edge, which is the first edge of wall B. So again, leading is the first edge, trailing is the second edge. So right now, wall A is relative to wall B, and it's extending to its trailing edge. I have that set as a square treatment because it's a square wall. I don't need to miter that or anything like that, so I can leave that set to square. I don't need an offset in here. I don't need to flip the ends, and I want that to be a 3-stud corner. Again, you can apply different stud counts to the ends if you want to, but that's where we're getting that 3 studs from. So 1, 2, 3 studs on that wall. Wall B is relative to wall A, and it's going to its leading edge. It's the first edge it intersects. So that is the leading edge. Again, it's square, no offset, no flipping the end, and I want that to be just one single stud to create that 4-stud energy corner, or that 4-stud corner. And that will create that configuration for us. When we look at the very top plate, what we're doing here is I can turn off the core. So now we're only seeing the actual top plates, and I have an overlap happening here. So now I have wall A and wall B. So wall A is relative to wall B, but it's going to its leading edge. So wall A is going to the leading edge, and wall B is relative to wall A to the trailing. So I create that overlap of my corner. So when I'm attaching my top plates, there's an overlap happening to help strengthen that corner. Down in the bottom here, we have a option called Apply to Similar Intersections. And if you are adding in a new configuration, the configuration will be applied to all intersections similar to the one that is current. In the Apply to Similar Intersections area, you can select either a basic match, a moderate match, or an exact match to determine how similar the intersections must be to the current one in order to receive the new configurations. A basic match is the intersection has the same shape, same number of walls and nodes within the intersection. A moderate match is the intersections have the same shape and angle between the walls. An exact match is the intersection has the same shape, angle between the walls, and orientation. We also have a make default for matches of selected strength. And we will use this configuration for intersections of this type when new walls are created. And majority of the time, you're going to want this set to moderate match. That's usually what this will be set to. So basically, it's saying anytime that I have 2 walls that come in at this angle, this is the type of configuration I want to use. I'm going to click cancel on here and here. And I'm just going to turn this into a framed view. So I'm going to turn off framing mode and turn on my display framing. And I'm going to again turn this into a rendered outline. And we can now see how this wall is going to be framed with these new options that we adjusted. So I have the different opening header for that opening there. And I have my 3 walls here set to use a blocked wall instead of just a 16-inch on center double top plate. So that goes over everything I wanted to talk about today in regards to wall framing. So I'm going to go over a quick review of what we've covered today. So if you do have any questions, please feel free to go ahead and type those into the questions area, and I will go through and answer any questions that have come up. So Envisioneer provides a number of options for determining how your model will be framed. You can customize your model's framing configurations to suit your specific construction needs and preferences. By default, walls are framed according to the framing options set in your building locations. Every location has its own framing settings, which include an infill configuration, a span table selection, and a framing rule. You can create or customize your infill configurations, be it your bottom plate, top plate, studs, and blocking, in the Wall Infill Library, and then apply them to locations or to individual walls in your model. Your location framing options include a span table selection for load-bearing walls and one for non-load-bearing walls. You can add and edit span tables to ensure your openings are framed the way you want. Framing mode allows you to override the location framing options and specify custom settings for individual walls, openings, and intersections in your model. So again, I'm going to go ahead and open up the questions section. So if you do have any questions about what we've talked about today, please feel free to go ahead and type those in, and I'll answer any of those questions for you. And while I wait for a question, I'm going to just go back into a 2D plan view, and I want to show an option for adding in a larger header. Now, I was doing this to a particular wall here, but since it's so close to the top plate, it wouldn't allow it. So I'm going to go back into display all but framing. I'm going to add in a garage door. So I'm just going to drop in a garage door. We'll just do a double door here, and we'll drop that in to this wall right here, and we'll say center on wall. I'm going to lower this down because this wall will actually be a bit lower. So I'm going to go -1 foot 5 inches, and we'll say apply and OK. So essentially what I've done, if I look at this in our 3D view, and I just kind of pull my camera back here, I have a new door in my design, and I can see that it's a bit lower. If I go into a framing mode, it's not going to show me any configuration here because it's a larger opening. It hasn't been defined, so it's not showing me anything. So I want to take care of that. So I'm going to go into my framing mode. I'm going to double click on that opening, and I'm going to say I want to specify my own custom configuration for that particular opening. I'm going to say select. And here's where I can say I want that to be an 11 7/8 PSL header. Again, I can go in and make adjustments to this so that I have the appropriate configuration set up. So be it however many jack and king studs that I want for that particular opening. And the type of header, I could say OK, and then OK, and then OK. And it will now add that opening header in for that wall. Since there is actually enough room for that size of header, it will add it in for me. Here, I can go back in and say, well, turn off display framing mode, and I want to show just the actual framing. And I can now see that particular header in that wall for just that one opening. So that's a better representation of what I was trying to show with that front door. This just allows you to see exactly how you can apply a larger header within a wall. As long as it fits within that wall, you can adjust the size of that header. So again, I'll leave that question section open for another minute. So again, if you do have any questions, please feel free to go ahead and enter them in. Like I mentioned at the beginning of the class, I will be sending out a PDF which covers everything we've talked about today. So you will have something to refer back to try out on your own as well. All right, well, there doesn't seem to be any questions coming in. So I do want to thank everybody for attending today. Hopefully you were able to get some new information about framing your walls from our webinar today. And if you ever have any questions, please feel free to give our support department a call. They'll be able to help you out with any questions you may have as well. Again, I want to thank you all for attending, and I hope you have a great day. Thank you very much.